Can you solve this math problem under 3 seconds? We are trying to find the value of t that when we raise t to the self, we are going to get 19. So here we are going to do trial and error. Like when we say 1 to the power of 1 is 1, then 2 to the power of 2 is 4. These two numbers are not 19 or close to it. 3 to the power of 3 is equal to 3 times 3, 9 times 3, 27. You have it as 27, which is more than 19. If you take other numbers, it will go further than what? 19. This actually shows that t is greater than 2 and t is also less than 3. That means the possible solutions of t is that 2 is less than t and t is less than 3. These are the ranges of values of t. So for us to look for t, what do? Well, first of all, add that t to power t is 19. So the first thing we look at this is that we are going to take the lane of both sides, okay? So that we can actually bring the power down first. So if you take the lane of t power t is equals to the lane of 19, okay? So you know that the the rule of logarithm, that when you have log of m to the power of n is equals to n log m. That's one of the laws of logarithm. So we are now permitted to multiply the power t to the log. So what do we have? We are having t ln t is equals to ln 19. On having this, we are almost close to the answer. But here, what can we do to get the value of t? Now we introduce one sweet function in math, which is called the Lambert W function. Okay, the Lambert, we call it the Lambert W function. What's this function all about? It says that when you have the Lambert W function of e to a is equal to a. Okay, so here we are, our goal is now to express this particular function we have here to be in form of the Lambert W function. So here we have t ln t is equals to 19. Okay, so what do we have to do? We know one thing, that we know that when we do exponential ln t, that is equals to t, because this exponent will cancel the lane, right? So we are going to rewrite t to be in terms of exponent ln t. So what do we have? We are having the function to now be, this particular function to be exponential ln t, which is now t, okay? Then ln t is equals to ln 19, okay? So on having this, what do? You can now see that this is also almost the same, but we have to rearrange the function so that it will be easier to apply this. Okay? Rearranging the function, we now start with ln t. We have it that ln t, exponential ln t is equal to ln 19 function. So we can now see that the Lambert W function of ln t exponential ln t is equal to the Lambert W function of 19. Okay, so if you have this now, you can now see that the output is now ln t, because our a is now ln t, our exponent is here, our ln t is now a, it's still the same. So we have this as ln t is equal to the W function of 19. Okay, so what do we do to get out this lane? We take the exponents of both sides, since exponent removes the natural log. So what do? We have it, the exponential ln t is equal to exponential W function of 19. Okay, so at this point, you can now see that this exponent will reduce the lane. you can now see that our t is equal to the exponential of the w function of 19. And that's the what? Answer. If you found the video helpful, please do well to like, comment, and share for more exciting math tips like this.